So now finally we're going to look into dividing fractions. And these often do seem a little bit daunting, but once we understand things that we've been talking about in previous videos, so fractions of a quantity, the idea of a reciprocal, and how dividing by a whole number is the same as multiplying by the fraction of its reciprocal, as well as multiplying fractions in general. Since we've built up a strong foundation here, these fractions, and when we divide them, they become a lot easier to work with. So I've included a couple of examples here just to warm us up. And first of all, we're looking at 8 divided by 2. Not a pretty comfortable sort of problem to work with. I'm just going to draw 8 circles here just to build on our intuition a little bit. So we've got 2, 4, 6, 8. Now, I've been talking a lot about wording with multiplication and division and stuff like that. And this becomes somewhat significant when we look at division as well. So if I'm saying, all right, well, what's 8 divided by 2? We're essentially just saying, well, how many times does 2 go into 8? That's essentially what dividing is, right? It's kind of just the backwards step, essentially. When we divide 8 by 2, we're also essentially just looking at, well, how many times does 2 go into 8? So we see here, we have 1 lot of 2, 2 lots of 2, 3 lots of 2, and 4 lots of 2. So we got that. This happened 1, 2, 3, 4 times, right? So 8 divided by 2, we get to be 4 because 2 goes into 8 4 times. Let me fix that 4 up a little bit. Now, this is a bit problematic. This second example. Now, sorry, you'll have to excuse the plane flying over, but when we divide 2 by a half, well, it looks a bit trickier because we have a fraction this time, but the same principle kind of remains. Now, let's see why this is. So, I have, for example, 2 squares, right? And I'm essentially asking myself the same question. I'm telling myself, well, how many times does a half go into 2? Now, I have 2 holes here, so let's just draw up halves in these holes. Now we have half, 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 and half, right? And how many halves do we have in total? Well, we have 4 again. We have 1 half, another half, a third half, and a fourth half. So we get that this would be 4. But before I just flat out write the answer, let's see if we could have solved this as well using an opposite reciprocal idea that we talked about here. Because when we did, for example, well, 8 divided by 2, that was like saying, well, what's a half multiplied by 8? What is half of 8? Same thing here. We can say, well, okay, because we've established in that fractions of a quantity video that this reciprocal idea, when it comes to flipping between multiplication and division, it holds in the examples that we did and all examples of multiplication and division. Now, here in this particular example, we have that 2 is divided by a half. Now, that is the same as 2 multiplied by this reciprocal, 2 over 1. Now, this is 2 divided by 1 on this right-hand side. So this is the same as saying, well, this is just 2 times 2, which is 4, which is the exact amount of portions we shaded in here. We have 1, 2, 3, and 4 halves in 2 holes. Now, just by understanding this reciprocal makes things so much easier. Because now we can just go straight into a couple of examples. Because this won't change for other fractions. They look scarier, but the same thing holds. It's not too bad. Now, if I did, okay, half divided by a quarter, well, this is the same as just writing, well, this is half multiplied by 4 over 1. And from our multiplication of fractions video that we did previously, we essentially established a procedure, a one-size-fits-all procedure for computing these. We multiplied our numerators and we multiplied our denominators. So here we get 1 times 4, which is 4, divided by 2 times 1, which is 2. 4 divided by 2 gives us 2. Now, we'll look at one more example just to show you essentially the benefit of what we know about reciprocals in solving these division of fractions problems. Now, what if we were to do, in example 4, we wanted to find 3/4 divided by a half. So, a very similar thing happens here, because our 3/4 stays, because we're essentially just trying to find, well, how many times does a half go into 3/4? And we can write that, okay, this is like multiplying by 2 over 1. And eventually, once again, we can multiply top and bottom. So 3 multiplied by 2, we get 6. And 4 multiplied by 1, we get 4, which 2 goes into both of these, top and bottom. So we can simplify this to this improper fraction of 3 over 2. So when we encounter these types of scary division of fractions, we can simply just draw upon the intuition we gained before from multiplying fractions, as well as the reciprocal when taking fractions of a quantity. And these things we looked at in the first 2 examples, they hold in our examples 3 and 4, and which I've shown in other videos. So that is the process for when we divide fractions. We can essentially, when dividing by a fraction, that is the same as multiplying by its reciprocal. And here the order matters a bit more, because, well, we're trying to find out, well, how many times does a quarter go into a half? So this is the one we're going to have to flip over and make its reciprocal and change the sign. And the same thing we saw in example 4. So it was this half that we flipped over, and we found eventually, after simplifying, 3 over 2. See you guys next time.